every system is quote unquote infinitely baitable because you can keep on adding features, keep on adding components, keep on adding stuff to it and just keep on growing it. Right. But how do you know that, hey, this is where I need to stop? How do you know that you have debate a good system? Because you might just draw 6 boxes and say, yeah, this is what my system is all about. But hey, is this good enough? Is there a quantification? Is there some way I can say that, hey, this is a good system? And so this is where I'd love to talk about how do you know that you have built good system? First, that you have broken your system into components. That when if it was thrown at you, design something. You just didn't draw a. If I'm asking design Facebook, I just draw one box, Facebook, and that. Right? Breaking things into components, having that clarity in your head is important. So first step, you know that you have built a good system when you broke it down into components. Second, the components that you broke down, each one of them has clear set of responsibilities. Really important. And in most cases, they need to be exclusive. So the responsibility of one component should not interfere with other, right? No matter what, having those mutually exclusive set of responsibilities is really, really important. I'll give an example. Let's say we take the same example of designing feed. In designing feed, we know we need web server, we need generator, and now I'm adding an aggregator. In the previous one, I didn't add aggregator because we are not sure, but now we know we need aggregator. Let me explain why. Because now you see clear separation of concerns between the three, right? So first, the web server. The role of the web server would be to serve feed over HTTP, which means what it would do, whenever it would handle the request coming in from the user. From the web server, it would go to database, fetch the feed, send it to the user. Now, the web server, because it is serving HTTP requests, it is serving requests to the end user, neither generator nor aggregator will do it. It's all. So that responsibility of serving end user HTTP request is only with web server, right? Reading from the database, other services may do it. It does not mean that, hey, only web server will read from this database. Even other services can, other components can also read from this database. No one's stopping them from doing it. But from the system's perspective, there is only one component that will be serving feed to the user. No one else would be doing it. Neither generator nor aggregator. Let's talk about generator. Now, the job of the generator would be to generate a candidate feed, which means it will not generate the final feed. It would do what it would do. It would go through all the sources, post service or the post service, follow service, and recommendation service, and pull all the details into a temporary database. Right? Okay, for this user, this is all the things I need to create the feed. This is what the generator would do. It would take all the items or all the things that it would find relevant enough, recent enough, and put it into this database. Now, this becomes the input to your aggregator. Now, what an aggregator would do? So, your aggregator's job would be to go through this temporary database for each user. It would say, hey, these are all the items. Out of these 10 I pick, which I'll put into the feed of this user. And it would pick the best one. It would filter out what's unnecessary, filter out low quality content, filter out things that user might not be excited about, and create the final feed and put into the feed database. Now here you see the clear set of responsibility. First, web server is serving the end user stuff, talking to the database, reading and sending. Generator is pulling data from multiple sources and putting it into some temporary database. Aggregator is operating on this temporary database, creating the final feed and putting it into the database to be consumed by web server. Here you see how generator has mutual exclusive set of responsibilities. Aggregator has mutual exclusive set of responsibilities. Web server has mutually exclusive set of responsibilities, right? And they're all sharing the same database to do it. Now, how to scale databases and all, we'll talk about it when we cover databases, right? But you get this idea that how you're having clear set of responsibilities, which are non-overlapping, right? This is when you know you have designed good system because this tells that you are not just drawing boxes for the sake of it. You have given thought. You have some very rational, you made a very rational decision the way you have split it into components. Very important to do so, right? Third thing, for each component, like how do you know you build good systems? Third point, for each component, you have slight technical details figured out. For example, database and caching, scaling and fault tolerance, asynchronous processing, communication, the four parameters that we looked into the previous video. The same for parameters for every single subcomponent that you have. Because it might be possible a day. Like for web server, should not be anything that is asynchronous there. In case there is, you add it. Otherwise, you don't add it, right? Communication might be pretty straightforward HTTP, but have those details figured out. Once you have those details figured out, you know that it's not just random boxes that you drew. It is very thoughtful. Right? These are the technical details around each one of this component. That's when you know you've designed a good system. And the final point is that each component in isolation is scalable, fault tolerant, and available. Right? So in the previous one, we talked about the technical details of it. Now, extending to this is around how each one of those components scalable, fault tolerant, and available. For example, is my database scalable or not? Which database am I picking? Why am I picking a certain database? What happens if I get large number of requests? How would I scale it? You need to think about scaling this database. What if there are millions of users coming in? How do I generate feed for millions of users? So then adding more machines to do it, having those logics in place. Okay? Then when I have huge number of feeds to aggregate, how would my aggregator work in parallel for millions of users? Okay? This is where your scaling comes in. Then comes fault tolerant. What if one of the web server goes down? If there are multiple web servers behind the load balancer, it's not a problem. But what if my database goes down? What if servers on my aggregator side go down? Right? Think about fault tolerance. Are you making your things tolerant to faults that would happen? And availability. Think about availability that, hey, what happens if one of the server goes down, which my system still available? Is there any subcomponent in my system that if it goes down, it is a complete outage? If that is the case, solve that, right? There should not be any component which is single point of failure, right? Once you cover all these 4 points, you know you have made a good system. And this is the framework that I use to evaluate any system that I create. I'm just sharing with all of you, and every single thing that we talked about, we'll do it consciously in every single system we design. Right? And this is precisely how we will tackle every system. Structured way and in a very detailed manner. Right? So that's all what I wanted to cover in this one. I hope you found it interesting. Hope you found it amazing. That's it for this one. I'll see you in the next one. Thanks, Ada.